In this problem, we're asked to graph 3e to the x minus 2. And if you've been watching all the videos, then this might feel like very old news. But so we're going to start by graphing our parent function, which always has the form y equals b to the x, where b is whatever base you're given in the problem. So in this case, our parent function is y equals e to the x. Now, functions of that form b to the x always contain these three specific features. They always go through the point 0, 1, so we could go ahead and plot that. They always go through the point 1 and then whatever the base is, so base e, which now we would want to be aware that e is approximately equal to 2.7. It goes on from there, but as far as, if I have any hope of graphing this accurately, I don't want to go past the 10th place. So x coordinate is 1, y coordinate is about 2.7. So I'll just put that here, between 2 and 3, closer to 3. And they all have a horizontal asymptote at y equals 0. Here. Okay, and then I just do the best I can to draw the shape of that exponential function when the base is bigger than 1. Looks like this. And so this is the graph of e to the x. Once we get that on the page, then we take a step back and consider, okay, so what needs to happen for me to turn this into the graph of 3 times e to the x minus 2? So there's two transformations that need to occur. We've got that minus 2 inside of the exponent, so that's inside the function. That's going to be a horizontal shift. Horizontal shifts kind of do the opposite of what you would expect maybe if you didn't know anything about transformations. But so minus 2 actually goes forward 2. It goes right 2. The horizontal shifts are kind of counterintuitive in that way. There's 3 times the function. So that's a vertical stretch by a factor of 3. And so the way we actually perform those vertical stretches is we multiply the y coordinates of our parent function by 3 in this case, whatever that coefficient is. It may be helpful also, before I start applying this transformation, to label the equation of your horizontal asymptote. Sometimes that's helpful when you're trying to figure out, okay, what effect does the transformation have on that horizontal asymptote? All right, so I'm going to go one feature at a time. I'll go ahead and start with the asymptote, since we're kind of talking about it here. So you've got this horizontal asymptote at y equals 0. I want to perform the transformations now on that asymptote. So shifting it right 2, this horizontal asymptote goes on forever in both directions, so shifting it right 2 has no effect on the graph. But multiplying the y value by 3, let's think about that. So y equals 0. If I multiply by 3, that's still 0. That's 0 times 3. It's still 0. So the horizontal asymptote is going to stay at y equals 0. This will be the horizontal asymptote for our transformed graph as well. Okay, but the points are most likely going to move. So let me start with this point at 0, 1. If I shift it right 2, okay, so it's going to move here to 2, 1, and now multiply the y coordinate by 3. So the y coordinate here is 1, multiplied by 3, now it's going to be 3. So that point is going to land here again. It goes right 2. Then I consider, okay, the y coordinate right now is 1, so times 3. I wind up with a point at 2, 3. Now if I work with this second point at 1, 2.7, I move right 2, so now I'm at 3 and then about 2.7. And then I need to multiply the y coordinate there, 2.7, times 3. And so when I do that, I get about 8.1. So I'm here, oops. Okay, I'm here right now. I multiply the y coordinate by 3. That's going to stretch the y value up to 8.1. And I'm sorry, I can't get rid of that e to the x. So the point at 1, comma e got transformed to this point at 3, and then about 8.1 up here. So now I want to draw an exponential curve through this point, and then it has to follow the horizontal asymptote at y equals 0. So you just do the best you can to sketch that curve. I'll have it going up this way through those 2 points, and then down this way through those points.